In the deepest hours of night, when the world lies hushed beneath a blanket of stars, there exists a particular kind of silence. Not an absence, but a presence. A space between heartbeats where the universe whispers its oldest stories. It is in this silence that we find ourselves tonight, gazing upward through the thin veil that separates our brief lives from the eternal. The stars above us have witnessed the entire history of our species, yet they themselves are mere children in the cosmic narrative. They have watched empires rise and crumble, civilizations bloom and wither, all while continuing their patient procession across the heavens. These celestial companions mark our hours and seasons, guiding sailors home and inspiring poets, since the first human eyes turned skyward in wonder. And yet, for all their constancy, the stars themselves are transient, born in the fiery collapse of nebulae, burning for millions or billions of years, then fading or exploding in spectacular finales that seed the cosmos with the elements of new creation. And somewhere among them, moving with purpose through the void, travels a visitor that defies our understanding, a stranger from beyond our solar shores, silent yet somehow speaking, distant yet intimately connected. To our deepest questions about existence, they noticed it first as nothing more than a faint smudge. Against the backdrop of infinity, astronomers, keeping their patient vigil through the night. In mountain observatories where the air thins toward space, in radio telescope arrays stretched across desert plains, in the quiet control rooms where digital displays render the invisible visible, they maintained their eternal watch. A routine observation, another point of light tracked across the celestial sphere, one of thousands documented each year in the patient cataloguing of the cosmos. They called it Three-Eye Atlas, a designation both clinical and inadequate, like naming an ocean wave or a gust of wind, an attempt to classify what might transcend classification. The preliminary data suggested a comet, one of countless icy wanderers that drift through our system, periodic visitors that have inspired both fear and wonder throughout human history. But even in those early calculations, hidden within the raw numbers and spectral analyses, something felt different. Its motion carried a quality that the mathematics alone couldn't capture, a deliberateness that seemed to defy the cold equations of orbital mechanics. The trajectory calculations yielded results that were precise, yet somehow incomplete, as though measuring the path of a dancer using only angles and velocities, missing entirely the intention behind the movement. It moved not as an object surrendered to gravity's pull, but as a traveler following remembered paths through star systems it had perhaps known before, like an ancient pilgrim retracing steps on a sacred journey begun eons ago. The computers tracked its trajectory, plotted its course with digital precision, yet couldn't quantify the strange sense of intention that seemed to guide it, couldn't capture in algorithms what the human observers felt when they considered its passage. How does one measure purpose in the movement of distant ice? What equations could possibly account for the whisper of meaning that seemed to emanate from this silent wanderer? Unlike the comets born of our own Oort cloud, those familiar visitors whose paths we've charted for centuries, whose periodic returns mark the passing of human generations, Three-Eye Atlas arrived from elsewhere, from the vast interstellar medium, where distances are measured not in millions but billions of miles. It emerged from a darkness so profound that even our most powerful telescopes can barely penetrate it, a void between stars where a single photon might travel for years before encountering matter. It carried no origin story we could read, no stellar parent we could identify with certainty, no birth system whose chemistry might explain its composition. It was a fragment from an unknown whole, a messenger without a clearly identifiable sender, a chapter torn from a book written in a language we have not yet learned to decipher. Its composition whispered of chemistry from worlds beyond our reach, of elements arranged by processes we might never witness, of ice formed perhaps before our own sun ignited in its stellar nursery. The spectroscopic analysis revealed familiar compounds, water, carbon dioxide, ammonia, yet arranged in ratios that hinted at formation under conditions unlike those in our own solar system, a subtle alienness embedded in its molecular structure. The astronomers who studied its approach spoke of it in terms of velocity and trajectory, of albedo and composition, focusing on what could be measured and quantified. Yet in their quiet moments, in those hours when science gives way to wonder, when the professional yields to the personal, They found themselves drawn to more profound questions. What ancient light had warmed this traveler before ours? What gravitational hands had shaped its path before it found its way to us? What cosmic storms had it weathered in its journey across the interstellar deep? These questions lingered in observatories and university hallways, in late-night emails and conference presentations, unspoken but present, like shadows cast by the instruments of science themselves. It drifted through our awareness like a fragment of some cosmic dream, neither bound to our sun nor merely passing through, but somehow choosing its own way forward through the silent deep, carrying with it mysteries older than our civilization, perhaps older than our planet itself. The light that reflected from its surface told stories that instruments could record but not entirely comprehend. As sunlight bounced from its distant form and traveled through the vacuum to reach our telescopes, it carried information encoded in its spectrum, the particular wavelengths absorbed and reflected, revealing the chemical composition of the visitor's surface. Spectrographic analyses revealed expected compounds, water ice, carbon compounds, the usual suspects that make up the wanderers of deep space, the common vocabulary of cosmic chemistry. Yet within these readings lay anomalies, subtle variations that couldn't be immediately explained away by reference to known processes or compositions. Elements appeared in unexpected combinations. Isotope ratios differed slightly from predictive models, suggesting origins in stellar forges, unlike those that created the matter in our own system. More curious still were the fluctuations in its brightness, not the steady reflection one might expect from a tumbling piece of cosmic debris, but rhythmic pulses that seemed to follow patterns just beyond the edge of recognition, like a poem written in meter we almost but don't quite understand. The light curve data showed regular variations that defied simple explanation, not the random flickers of an irregularly shaped object rotating in space, but something more ordered, more intentional in its rhythm. Observatories from Mauna Kea to the orbiting telescopes above Earth's atmosphere measured these subtle changes, cataloguing them with scientific precision while privately wondering at their cause. Teams of researchers analyzed the data through long nights, plotting graphs that revealed patterns too regular to be random, yet too complex to be easily categorized. The silence between those pulses of light felt weighted somehow, like pauses in conversation, when meaning hides between words, when what remains unsaid carries more significance than what is spoken. Was it merely the random play of light across an irregular surface, the consequence of some peculiar but natural formation process in deep space? Or was it something else, a cosmic Morse code tapped out across billions of years, arriving at our doorstep like a message in a bottle cast into an ocean of stars? The data alone could not answer, but in the quiet hours when screens glowed in darkened rooms and tired eyes searched for patterns in the numbers, the question lingered, unspoken but insistent. As 3i Atlas approached the gravitational influence of our Sun, the mathematics that predict the motions of celestial bodies stood ready to chart its course with precision. The equations of orbital mechanics, perfected over centuries since Kepler and Newton first described the clockwork of the heavens, waited to embrace this new visitor, to fold it into the elegant mathematical framework that has guided our understanding of cosmic motion. The gravitational pull of our star should have bent the comet's path in a precisely predictable hyperbolic curve, the universal language of physics, applying to this interstellar wanderer just as it applies to planets, asteroids, and spacecraft within our system. Yet here again expectations surrendered to mystery. Where the comet's path should have bent in predictable ways, following the smooth arc prescribed by gravitational equations, it showed subtle variations, minor adjustments that suggested either an incomplete understanding of cosmic physics or something far more profound. The deviations were small, almost at the limit of measurement precision, yet they persisted across observations, confirmed by multiple instruments and analysis teams. It moved with a grace that seemed to defy the cold certainty of Newtonian mechanics, shifting its trajectory with what almost appeared to be choice. The word remained largely unspoken in formal discussions, but it haunted the margins of scientific papers and the late-night conversations of research teams. Scientists debated these anomalies in conference rooms and over late-night video calls. proposing alternative explanations, perhaps outgassing creating tiny propulsive forces, perhaps interactions with the solar magnetic field, perhaps measurement errors or instrument artifacts. Yet as each alternative explanation was systematically examined and found insufficient, their voices grew quieter as the implications deepened, as the boundary between the known and the unknown became increasingly porous. For what does it mean when something cold and silent, something formed in the depths beyond our comprehension, begins to move in ways that suggest not just reaction, but response? What does it mean when gravity itself seems to hesitate before a visitor from the stars? These questions lingered in the data, in the spaces between confirmed observations and tentative interpretations, challenging not just our understanding of celestial mechanics, but our conception of intention and awareness in the universe. The scientific community found itself revisiting memories of another interstellar wanderer, Oumuamua, that peculiar, elongated object that had passed through our system years before, generating similar questions and similar wonder. That visitor too had defied easy categorization, its flattened, elongated shape, unlike typical asteroids or comets, its surface properties inconsistent with known formation processes. It had accelerated slightly as it departed our sun, as if pushed by forces unseen, following a trajectory that hinted at propulsion rather than passive response to gravitational forces. The debates sparked by Oumuamua had never fully resolved. They had simply faded, as the object itself faded from view, leaving behind questions that lingered like smoke after a fire has died. Now with 3i Atlas, those questions reignited, burning with renewed intensity as similar anomalies appeared in this new visitor's behavior. Were these travelers related somehow? Products of similar formation processes in some distant stellar nursery? Cousins cast adrift from the same distant shore? Or perhaps something more profound? Evidence of a pattern repeating itself across vast scales of space and time, hinting at purpose where we expected only the random drift of cosmic flotsam. The parallels between these visitors created a kind of narrative tension in the scientific literature, a story unfolding across years of observation and analysis, connecting disparate research teams and observational platforms in a shared mystery. In conferences and journal articles, researchers noted the similarities with scholarly caution, careful to maintain scientific skepticism while acknowledging the striking coincidence of two interstellar visitors exhibiting similar anomalous behaviors within a relatively brief span of astronomical time. For patterns suggest meaning, and meaning suggests intent, and intent, in the cold emptiness between stars, raises questions that science alone cannot answer. Questions that reach beyond the realm of the measurable into the territory of the philosophical. As 3i Atlas continued its journey through our system, it carried not just its own mystery, but echoes of Oumuamua's passage, creating a sense of repetition, of visitation, perhaps even of communication across the years. A conversation conducted not in words but in trajectories, not in sounds but in the silent language of motion through the void. The mathematics of 3i Atlas's journey revealed impossibilities dressed as anomalies, discrepancies that hovered at the edge of measurement error, yet persisted across multiple observations and analysis methodologies. Small accelerations appeared in its motion that couldn't be accounted for by the standard models of cometary behavior, tiny adjustments in velocity and direction that occurred without visible cause, that defied the expected gravitational choreography of an object moving through our solar system. The changes were subtle, fractions of a centimeter per second squared, yet they accumulated over time into deviations that could not be ignored or dismissed. The precision instruments of modern astronomy, from ground-based adaptive optics to space telescopes floating above Earth's atmospheric distortion, all confirmed these variations, these deviations from expected behavior. Some scientists spoke of outgassing, the release of trapped gases as ice worms in the sun's presence, creating minute propulsive forces that could alter an object's trajectory, a well-understood phenomenon that explains the beautiful tales of traditional comets. Others suggested interactions with solar wind or magnetic fields, invisible forces that might nudge an object as it travels through the complex electromagnetic environment of our star system. The hypotheses multiplied in research papers and conference presentations, each attempting to fold the anomalous into the understood, to transform mystery into mechanism. Yet the precision of these adjustments, their timing and direction, their apparent correlation with specific positions relative to Earth and other planets, left room for more profound interpretations. The equations balanced on paper, the models ran smoothly in supercomputer simulations, yet the meaning they described remained elusive, like a poem translated too literally from an alien tongue, preserving syntax while losing essence. In late-night discussions that drifted from science into philosophy, in quiet conversations after formal presentations had ended and projectors had been switched off, some began to wonder if perhaps motion itself could carry meaning, if the very way an object moves through space might be its own form of expression, its own kind of language. What if the deviations in 3I Atlas's trajectory were not errors in our understanding or measurement, but communications, a form of expression that used position and velocity as its vocabulary, gravitational interaction as its grammar? The thought remained speculative, rarely finding its way into peer-reviewed literature, yet it persisted in the imagination of those who had spent the most time with the data, those who had followed the visitor's path most closely, like a melody that continues to play in memory after the music itself has ended. In radio observatories scattered across Earth's quietest places, in valleys shielded from human-made signals by surrounding mountains, on plains where the air hangs still and silent, in remote deserts where the only sounds come from wind moving across ancient stone, massive dishes turned their patient gaze toward the visitor. These technological ears, some spanning hundreds of feet in diameter, listened across the electromagnetic spectrum, from low-frequency waves that ripple slowly through space to the higher frequencies where intelligent transmissions might hide. They filtered out the cacophony of human civilization, the radar pings, television broadcasts, and cellular communications that fill our local environment with noise, seeking signals from the deep sky, from the silent traveler moving through our system. Hour after hour, day after day, they collected data, processing it through algorithms designed to detect patterns in the cosmic background, to separate signal from noise across vast distances. No clear signal came, no structured transmission that could be unambiguously identified as artificial, no repeating sequence that announced itself as a message from elsewhere. Instead, they recorded only the eternal background hum of creation, the faint echo of the universe's birth, still reverberating after billions of years, the cosmic microwave background radiation that fills all of space as a reminder of the Big Bang's primordial fire. But within that cosmic static, within the sea of random electromagnetic fluctuations that constitutes the universe's ambient sound, patterns emerged at the very edge of detection, correlations and repetitions that statisticians could neither confirm nor dismiss with confidence, that hovered in the territory between significance and coincidence. Data analysts applied increasingly sophisticated algorithms, searching for structure, in what appeared at first glance to be randomness, for information encoded in what might be merely noise. They found suggestions of order, whispers rather than shouts, hints rather than declarations, possibilities rather than certainties. Perhaps the signal and the silence were one and the same. Perhaps the absence of a clear message was itself the message, a reminder that communication need not follow human expectations to carry meaning across the void. In the quiet of their observation rooms, surrounded by screens displaying waveforms and spectral analyses, researchers contemplated this possibility, that we might be listening for the wrong kind of voice, expecting the wrong kind of word from a traveler whose nature and purpose lay beyond our current understanding, like ancient sailors listening for speech in the sound of waves or the cry of seabirds, missing entirely the stars that could guide them home. Closer examination of 3I Atlas revealed structures that defied conventional understanding of cometary formation. As higher resolution imaging became available, as adaptive optics and computational photography extracted more detail from the distant object, astronomers began to discern features that couldn't be easily explained by reference to known formation processes. Beneath the expected irregularity of its icy surface, beneath the chaotic topography typical of comets and asteroids, lay hints of symmetry, angles and proportions that mathematical analysis suggested were improbably precise, geometric relationships that seemed to transcend the random accumulation processes believed to form most small bodies in space. Statistical analyses confirmed what the eye perceived intuitively, that certain features repeated with a regularity unlikely to occur through chance alone, that certain proportions appeared consistently across different regions of the object. Natural processes tend towards certain kinds of order. Certainly, crystals form in geometric patterns, cooling lava creates hexagonal columns, flowing water carves symmetrical features in stone. But the patterns observed in this interstellar wanderer suggested something else. Something beyond the usual operations of physics and chemistry in space. It was as though long ago, in some distant system circling a star we might never know, something or someone had shaped this object with purpose before sending it drifting through the interstellar night, like a message carved into a bottle before being cast into the sea. The comparison became increasingly apt as further details emerged, details that suggested not just natural symmetry, but functional structure, features that hinted at design rather than accident. Like finding straight lines and perfect circles in the growth rings of an ancient tree, like discovering prime numbers encoded in the pattern of a seashell, the geometry hidden within 3i Atlas whispered of design where we expected only the chaotic beauty of natural formation. It drifted through our awareness, like an artifact from a civilization lost to time and distance, like a fragment of some vast structure disassembled ages ago, carrying its silent history across gulfs of space too vast for human comprehension, preserving in its form some echo of minds that thought and hands that built in light from stars now long extinguished. Perhaps the mystery of 3i Atlas lies as much within us as within the comet itself. Our search for meaning in its passage, our attempts to decode its structure and behavior, our wonder at its origin and purpose, these may reveal more about human consciousness than about the nature of the visitor. Each generation of humanity has projected its hopes and fears onto the unknown, seeing gods in the thunder, faces on the moon, canals on Mars, messages in the random distribution of stars across the night sky. From ancient cave paintings depicting celestial events to modern scientific hypotheses about extraterrestrial life, we have continuously populated the cosmos with reflections of our own awareness. Our need to find meaning shapes what we perceive, coloring our observations with the hue of our deepest desires, filtering raw data through the lens of our evolutionary heritage as pattern-seeking creatures who survived by finding signal in noise, by distinguishing the tiger's stripes from the dappled forest shadows. Perhaps this interstellar visitor is no machine or messenger, but simply a mirror, reflecting back our longing to find intelligence beyond our isolated world, our hope that we are not alone in the vast silence of space, our fear that we might be. In seeing potential design in its structure, in detecting possible purpose in its movement, we may be engaging in a form of cosmic pareidolia, finding faces in the random arrangement of craters, reading messages in the arbitrary pattern of surface features, discovering intention in the chance interactions of gravity and momentum. Yet even a mirror can teach us profound truths, showing us not just what we are but what we hope to become. In searching for meaning in the movement of distant ice, in questioning whether consciousness might take forms vastly different from our own, we reveal our own nature as creatures of curiosity and wonder, forever reaching beyond what we know toward what we can only imagine. We demonstrate our capacity to consider perspectives beyond our immediate experience, to entertain possibilities that transcend our evolutionary history. The true revelation may not be what 3i Atlas is, but what it reveals about us as we gaze upon it from our small world, circling an ordinary star in the outer reaches of an average galaxy, that we are beings who look upward and wonder, who measure and question, who seek connection even across the cold emptiness of interstellar space. With each new observation, with each new measurement and analysis, certainty about 3i Atlas dissolved like morning mist under the rising sun of wonder. What began as a straightforward tracking of an interstellar object, a routine exercise in celestial mechanics, evolved into a conversation about the nature of knowledge itself, about the limits of what we can know and the boundless territory of what we can question. The accumulation of data, rather than narrowing the range of possible interpretations as scientific investigation typically does, seemed instead to expand it, each new discovery raising more questions than it answered, each resolution of one mystery revealing deeper enigmas beneath. The comet's behavior continued to dance along the boundary between explanation and enigma, between the comfort of known physical laws and the disquieting possibility of phenomena beyond our current understanding. The scientific method itself, with its emphasis on testable hypotheses and reproducible results, seemed at times inadequate to the task of comprehending this visitor. For how does one test hypotheses about an object that may be unique, that offers no opportunities for comparative analysis or experimental manipulation? Scientists found themselves in the unfamiliar territory between disciplines, astronomers consulting with philosophers about the nature of intention, physicists debating with linguists about the possibility of communication through motion, biologists considering whether consciousness might exist in forms radically different from Earth's carbon-based life. These conversations crossed traditional academic boundaries, creating new intellectual spaces where different methodologies and perspectives could combine in unexpected ways. Traditional scientific conferences gave way to more interdisciplinary gatherings, where specialists from diverse fields attempted to construct a framework for understanding something that resisted categorization. That seemed to exist in the margins between our established ways of knowing. Was 3I Atlas merely a natural phenomenon too complex for our current models to predict, an object whose behavior would eventually be explained through advances in our understanding of physics and astronomy? Or was it something more? An artifact of intelligence, a message, a probe from civilizations lost to time or distance? The question itself became a kind of Rorschach test, revealing the philosophical predispositions and intellectual backgrounds of those who considered it. The truth began to feel secondary to the wonder it inspired, as though the questions themselves had become more valuable than any answers they might eventually yield, as though the visitor's greatest gift was not information, but inspiration, not revelation, but the renewal of mystery in a world increasingly convinced of its own comprehensive understanding. As 3I Atlas drew nearer to our sun, bathing in the increasing warmth of our star, its physical transformation began, yet not in ways that country science had prepared us to expect, not following the familiar pattern of sublimation and tail formation that characterizes the approach of ordinary comets to our star. Traditional comets, as they near the sun, develop distinctive tails as their icy surfaces begin to vaporize in the increasing heat, releasing gas and dust that stream away from the comet's nucleus, pushed by solar radiation and the solar wind. This process is well understood, documented in countless observations across centuries of astronomical study. But this visitor seemed to undergo a more profound metamorphosis, one that followed its own rules rather than the established patterns of cometary behavior. Its surface shimmered like liquid glass in the increasing light, reflecting the sun with an almost fluid quality that defied easy explanation within the framework of standard cometary composition. Spectroscopic analysis revealed changes in its surface chemistry as it approached perihelion, its closest point to the sun. But these changes followed patterns unlike those seen in solar system comets, suggesting exotic ice compositions or structural properties previously unknown to science. And then, in a development that left observatories scrambling to document and understand, that caused emergency observation time to be allocated on space telescopes and planetary radar systems. It began to shed fragments, not in the chaotic manner of a disintegrating body succumbing to thermal stress, but in what appeared to be carefully timed and positioned releases. These fragments, some no larger than boulders, others approaching the size of small asteroids, moved away from the main body in formation, tracing geometric patterns as they separated like tiny companions honoring their greater whole. The precision of these separations, their timing relative to the comet's position in the solar system, the way they maintained specific distances from each other as they moved, all suggested a process more ordered than the typical fragmentation observed in solar system comets. In the quiet control rooms of observatories around the world, in the data analysis centers, where information from multiple instruments was combined and processed, scientists watched this display with a sense of witnessing something both beautiful and impossible. A dance of ice and stone performed against the infinite backdrop of space, a choreography that hinted at purpose, where only physics should prevail. Each fragment released from 3I Atlas behaved with what could only be described as coordinated precision, moving not as independent objects surrendered to the random play of gravitational forces, but as elements in a complex system maintaining relationships with each other and with the parent body. They aligned themselves into spiraling patterns before scattering again in new configurations, executing maneuvers that seemed to follow some predetermined sequence, like participants in an elaborately choreographed ballet whose meaning remained obscure but whose beauty was undeniable. Tracking these fragments became a priority for observatories worldwide, each movement documented, each position plotted, each relationship between objects measured and analyzed. The fragments moved not with the simple physics of ejected debris, but with the complex harmony of intentional choreography, their path suggesting communication or coordination beyond what current models of cometary fragmentation could explain. Some researchers pointed to electrostatic forces or interactions with the solar magnetic field as possible explanations for these movements, known physical phenomena that might, under certain circumstances, create ordered patterns in the behavior of charged particles or objects with particular magnetic properties. Others suggested more exotic possibilities, new physics operating at scales or under conditions not yet fully explored in terrestrial laboratories, natural processes unknown to current science but potentially discoverable through further observation and analysis. Yet others fell silent, watching the celestial ballet unfold with the quiet recognition that some phenomena lie beyond our current capacity to explain, that the universe may contain mysteries that our current scientific paradigms cannot accommodate, like medieval scholars, confronting for the first time evidence that contradicted their established worldview. The spectacle carried with it the unmistakable grace of purpose, as though the comet were not simply disintegrating under the sun's warmth, but transforming itself, perhaps fulfilling some function encoded in its very structure, like a seed germinating when exposed to the right conditions after a long dormancy. In the silence of space, witnessed only by our distant instruments, Atlas seemed not to be dying but becoming something else, something that had perhaps been its destiny since it first formed in the darkness between stars, like an insect emerging from a chrysalis not as destruction but as metamorphosis, not as ending but as evolution into a new form of existence. Away from the major observatories, away from the peer-reviewed journals and official scientific channels, where caution and conservatism naturally prevail, amateur astronomers began reporting anomalies of their own, observations made with smaller telescopes and radio equipment, but no less significant for their modest origins. In an age of digital imaging and sophisticated software available to citizen scientists, in an era when the democratization of astronomy has placed powerful observational tools in the hands of dedicated amateurs, these observers formed a global network of independent witnesses to 3i Atlas's passage. With equipment set up in backyards and on rooftops, on balconies in light-polluted cities, and in remote dark sky locations, these citizen scientists detected phenomena that sometimes preceded official announcements from professional observatories, that occasionally revealed aspects of the visitor's behavior missed by more focused professional studies. Among the most intriguing were reports of faint radio emissions that seemed synchronized with 3i Atlas's motion and the movements of its fragments, weak signals detected not in the traditional communication bands where SETI projects focus their attention, but in seemingly random portions of the spectrum, appearing briefly before shifting to new frequencies. These signals, barely distinguishable from background noise, appearing at the very limit of detection, appeared to echo one another across different frequencies, like voices in a round, each picking up where the other left off, creating a complex pattern of overlapping emissions that suggested coordination rather than random generation. Amateur radio operators developed specialized software to track these emissions, sharing their findings through online forums and informal collaborations, creating a global detection network that operated in parallel with professional radio astronomy projects. The pattern suggested not random noise but harmony, not the chaotic emissions of natural processes, but the structured output of a system, operating according to some underlying pattern, a structure too orderly to be dismissed as coincidence, yet too subtle to be immediately accepted as evidence of design or artificial origin. Statistical analyses of these signals, conducted by professional scientists working with amateur data, revealed correlations that hovered at the edge of significance, patterns that could be neither confidently confirmed nor easily dismissed, that existed in the uncertain territory between signal and noise, where both meaningful communication and pattern-seeking human cognition operate. These whispers across the electromagnetic spectrum traveled through the night like a chorus of distant sighs, creating patterns of resonance where the models predicted only silence, suggesting connections between objects separated by thousands of kilometers of empty space. In online forums and private messages, in virtual conferences and informal data-sharing arrangements, these observers shared their findings with a mixture of excitement and uncertainty, aware that they might be witnessing something extraordinary, a form of communication or coordination that transcended current understanding, or perhaps simply finding patterns in the random static of a universe that owes us no explanations, that neither confirms nor denies our deepest hopes about our place in the cosmos. What if the mystery of 3i Atlas lies not in what it is, but in what it remembers? This question emerged in discussions that bridged astronomy and computer science, that brought together experts in artificial intelligence and planetary formation, creating new conceptual frameworks for understanding the visitor's behavior. Consider the possibility that this is not a living thing, not a vessel carrying biological entities across the gulf between stars, but something that carries the echo of intention, an artifact bearing the imprint of ancient programming, of commands left by those who once dreamed among distant stars in ages long past. Perhaps it moves not with consciousness as we understand it, but with purpose, following instructions embedded in its very structure, executing algorithms that have survived the eons of its journey through the interstellar void. Just as we have sent probes carrying golden records and digital messages into the depths of space, just as we have launched spacecraft programmed to execute missions long after direct communication becomes impossible, perhaps some other civilization, orbiting some other star, sent forth this messenger, not expecting a reply. Perhaps not even existing anymore to receive one, but reaching outward nonetheless in an act of cosmic communication across time rather than just space. Perhaps it has traveled for eons, moving between systems not with awareness but with purpose, like a message carrying itself across time, like a seed carrying genetic information toward some distant soil where it might eventually flourish. It may be replaying some forgotten function, executing instructions written by hands or minds that turned to dust, ages before our own sun formed from its stellar nursery, before our planet cooled from its molten origin, before the first primitive cells appeared in Earth's ancient oceans. The fragments it releases, the patterns it creates, the frequencies it emits, all might be components of some vast program running on substrates we barely understand. Using physical processes as its processing medium, space itself as its operating environment, and perhaps in its patient journey across the void, it has been waiting not consciously, but in the way that all messages wait, for eyes capable of noticing, for minds capable of wondering, for a species that might recognize in its movement not just matter obeying physics, but meaning encoded in motion. In this view, 3i Atlas becomes not just an object but an inheritance, a capsule of information sent by unknown precursors across gulfs of time that stagger the imagination, carrying within its structure and behavior the echo of minds that thought and created before humanity existed, before Earth as we know it had formed, perhaps before our sun itself had ignited in nuclear fire. Every discovery about 3i Atlas, every measurement and observation, every hypothesis and model seemed not just to reveal something about this interstellar visitor, but to reflect something about ourselves, about our methods of inquiry, our frameworks of understanding, our deepest hopes and fears about our place in the cosmos. In its mysterious trajectory, we saw our own longing for purpose. In its possible design, we recognized our need to find meaning in the universe. In its solitary journey between stars, we glimpsed our own isolation on our small world, circling an ordinary star in the outskirts of a vast galaxy. Our instruments recorded data in the form of light curves and spectrographic analyses, radio emissions and positional measurements, objective information rendered in the universal language of mathematics and physics. But our minds transformed that data into stories, narratives that helped us place this anomaly within our understanding of existence, frameworks that connected disparate observations into coherent patterns, metaphors that bridged the gap between what we could measure and what we could comprehend. These stories varied widely across cultures and disciplines, astronomers speaking of orbital mechanics and cometary structure, philosophers contemplating the nature of intention and design, science fiction authors imagining vast interstellar civilizations sending messengers across the void, religious leaders considering the theological implications of intelligence beyond Earth. Each narrative revealed as much about its author as about the object it attempted to describe, each interpretation colored by the cultural and personal context from which it emerged. Perhaps the most profound question was not what 3i Atlas was in itself, but why we looked to it for meaning, why we found ourselves drawn to its mystery, compelled to understand it not just as a physical phenomenon, but as a chapter in some greater cosmic story in which we too might find our place. In the visitor from beyond our solar system, we found a mirror that reflected not just light, but consciousness itself, our awareness looking back at us from the depths of space, our own questioning nature embodied in a distant object that raised questions we could formulate, but not answer. It reminded us that to observe is also to create, that the act of perception is not passive, but active, not merely receptive, but constructive, that we do not simply see the universe, but participate in giving it meaning through the very act of witnessing its unfolding. As 3i Atlas completed its closest approach to our sun and began its long journey outward, gradually receding from the warmth that had triggered its mysterious transformation, observers noted one final anomaly, a brief, almost imperceptible slowing of its velocity. The change lasted only hours, just enough to register in the most sensitive measurements, just enough to create a subtle inflection point in the smooth curve of its hyperbolic trajectory. The deviation was small but unmistakable, confirmed by multiple tracking stations and analysis teams, creating a brief moment of heightened excitement in observatories around the world. It was as though the visitor had hesitated momentarily before continuing its journey, as though it had paused to consider or to communicate or to complete some unobservable process before resuming its outward path. Scientists wondered if it had in some incomprehensible way acknowledged us, if this brief deviation represented some form of response to our observation, our radio transmissions, our very existence. The thought remained largely unspoken in formal discussions, considered too speculative for inclusion in peer-reviewed papers, yet it lingered in the consciousness of those who had followed the visitor most closely, who had dedicated months or years to tracking its progress through our system. Then, as if concluding a movement in some vast celestial symphony, as if completing one phrase in an ongoing composition, it resumed its previous velocity and continued on its path, slipping away from our star's gravitational embrace and back toward the cold immensity where light grows thin and silence reigns eternal. It carried with it the faint warmth of our attention, the invisible touch of our radio signals that had bathed it during its passage, the quiet echo of our wonder, encoded perhaps only in our own memory, but possibly in some way we cannot comprehend in its structure as well. And as it departed, as it gradually diminished in our telescopes from a resolvable object to a point of light to a barely detectable signal against the background of space, it left behind a sense not of ending, but of continuation, as though its journey through our awareness was merely one note in an ongoing composition too vast for us to hear in its entirety. A cosmic music played across scales of space and time that dwarf our brief existence, like a whale that rises briefly into human awareness before diving again into ocean depths, like a traveler glimpsed passing through a remote village before continuing on a journey, whose beginning and end remain unknown to those who witnessed only its middle. 3i Atlas returned to the mystery from which it had emerged, carrying with it questions that would outlast its visibility in our skies. What remained after 3i Atlas, passed beyond the reach of all but our most powerful instruments, were numbers, trajectories plotted as lines on graphs, velocities measured to decimal precision, light curves recorded as data points on charts, spectrographic analyses preserved as colored bands indicating elemental compositions. These measurements would be archived in astronomical databases, cited in research papers, incorporated into models of interstellar object behavior, becoming part of the growing corpus of knowledge about our cosmic environment. The scientific papers would be written, their cautious language describing observations without overreaching into speculation, their conclusions framed within the context of known physics, while acknowledging the limits of current understanding. The analyses would be completed, subjected to peer review, published in journals read primarily by specialists, occasionally filtered into more popular accounts that might reach a broader audience. The conclusions would be drawn within the careful language of empirical observation. This was measured, this was observed, these patterns were detected, these anomalies remain unexplained by current models. This is the vocabulary of science, the dialect of precision through which we attempt to translate cosmic mystery into human understanding. The research papers that documented 3i Atlas filled thousands of pages across dozens of journals, each adding a fragment to the mosaic of knowledge, each contributing a thread to the tapestry of understanding being woven by countless hands across the global scientific community. The data accumulated in massive digital archives, terabytes of information stored in climate-controlled server farms, backed up across continents, preserved for future generations of researchers who might bring fresh perspectives to ancient questions. Spectroscopic readings mapped the visitor's composition down to trace elements. Radio telescopes recorded the faint electromagnetic whispers that surrounded it. Optical instruments tracked its movement with precision, measured in fractions of arcseconds. Teams of graduate students spent sleepless nights processing raw data into meaningful patterns. Senior researchers debated the significance of statistical anomalies in conference rooms, scented with coffee and illuminated by the blue glow of projection screens. Yet none of these formal outputs, none of these professional products could fully capture the feeling that had settled into the scientific community during the visitor's passage. A sense that something profound had occurred, something that existed as much in the realm of meaning as in the realm of measurement, something that had touched not just instruments but consciousness. Behind the dry language of academic papers, beneath the precise measurements and statistical analyses, ran a current of wonder that could not be easily quantified or expressed within the conventions of scientific communication. This silent river of awe flowed through private conversations, through late-night emails exchanged between colleagues across time zones, through the quiet moments when researchers stood alone on observatory decks beneath the sprawling canvas of night, thinking not of data points, but of cosmic loneliness and connection. The visitor had catalyzed something beyond scientific curiosity. It had awakened an ancient human response to mystery, a recognition of the numinous that predates science itself, that reaches back to our ancestors who painted stars on cave ceilings and built stone circles to track celestial movements. The comet had become a dream disguised as data, a cosmic riddle translated into the language of astronomy, a visitor whose passage left behind not just information but transformation, subtle but undeniable, changes in how we perceive our place in the universe, in university hallways where framed photographs of nebulae and galaxies lined the walls, in planetariums where artificial stars wheeled overhead, while narrators explained cosmic processes to seated visitors, in classrooms where professors tried to convey both the facts and the wonder of astronomy to the next generation. The story of 3i Atlas became more than a case study. It became a parable about the nature of knowledge itself. It reminded those who studied it most closely that knowledge and wonder are not opposing forces, but complementary aspects of human engagement with the universe, that the scientific enterprise at its best combines rigorous methodology with boundless curiosity, precision with openness to mystery. The visitor challenged the false dichotomy between objective observation and subjective experience, revealing them as two sides of the same coin, two modes of awareness that together form the complete picture of human understanding. The numbers would remain in databases for generations to come, accessible to future researchers who might bring new analytical tools or theoretical frameworks to bear on the mystery of this interstellar visitor. Perhaps in decades or centuries hence, with more advanced technology and deeper theoretical understanding, some of the questions raised by 3i Atlas might find answers. Its composition might be better understood, its trajectory more completely explained, its origin more confidently identified. But so too would the questions remain, not just as problems awaiting solutions, but as doorways to deeper mysteries, as invitations to continue the endless human project of wondering. Questions that might never find complete answers, but would continue to inspire those who look upward, with both precision and awe, who seek to understand the cosmos not just through measurement but through meaning, not just through calculation but through contemplation. For in the end, science at its most profound is not merely about accumulating facts, but about deepening questions, not merely about explaining reality, but about engaging with it more fully, more consciously, more wonderingly. There exists a principle in quantum physics known as the observer effect, the recognition that the very act of measurement influences what is being measured, that the observer cannot be separated from the observed, that the process of investigation itself becomes part of the phenomenon under investigation. This principle, first articulated to explain the strange behavior of subatomic particles that seem to exist in multiple states until observed, has expanded beyond its original context to become a metaphor for a deeper truth about human engagement with reality, that we do not merely perceive the world but participate in it through the very act of perception. Perhaps something similar occurred with 3I Atlas, creating a relationship between observer and observed that transcended the vast distances of space. In the quiet control rooms of observatories, in the data analysis centers where information from multiple telescopes converged, in the offices where researchers pored over printouts and digital displays, a curious sense began to emerge, a feeling that the traditional boundary between subject and object had somehow blurred, that the relationship between human consciousness and distant comet had become something more complex, more interactive than conventional science could easily articulate. In studying it, in tracking its movement, in analyzing its composition and behavior, in directing our collective attention toward this visitor from beyond our solar shores, we became part of its story, just as it became part of ours. The electromagnetic, waves that bounced from its surface and traveled through vacuum to reach our instruments, became the medium of connection. Photons that had touched the comet's icy body eventually touching the human retina, creating electrochemical signals that became conscious perception, forming a physical link across the void. Our instruments, extensions of our senses, reached across space to touch what human hands never could, creating a technological bridge between consciousness and distant matter. Our interpretations, our hypotheses, even our disbelief, all became reflected in how we perceived its journey through our system. All colored our understanding of what it was and what it might mean. The visitor existed not just as an objective reality, but as a phenomenon embedded in human consciousness, interpreted through cultural lenses, understood through scientific paradigms, imagined through the filters of hope and fear that have always characterized humanity's relationship with the unknown. Maybe the act of observing had changed not just our understanding of the comet, but the comet itself, as though curiosity were a force of nature capable of altering the very fabric of reality, as though attention itself were a kind of gravity that subtly influences the path of what it contemplates. This thought lingered in the margins of scientific discussions, rarely finding its way into formal presentations or published papers, yet present nonetheless in the quiet conversations that followed official meetings, in the philosophical reflections that filled the gaps between data collection and analysis. The boundary between observer and observed blurred, creating a relationship where none should exist across the cold vacuum of space, a connection between conscious minds and distant ice that defied explanation, yet felt undeniably real to those who spent months tracking this visitor from beyond the stars. In the quiet moments between observations, in the gaps between data collection and analysis, in the silence of night as telescopes tracked automatically across the sky, those who dedicated themselves to understanding 3I Atlas sometimes felt this connection, not as a scientific conclusion but as an intuitive recognition, not as something that could be measured or proven, but as something experienced, like the difference between studying love through psychology and chemistry and actually falling in love. Some kept these thoughts private, concerned about maintaining professional credibility in a field that values objectivity and empirical evidence. Others found ways to express these reflections in more philosophical contexts, in essays about the nature of scientific inquiry, in discussions about the phenomenology of observation, in interdisciplinary forums where science meets philosophy and art. It was a recognition that perhaps in some way beyond our current understanding, consciousness itself is a cosmic force, that awareness may be as fundamental to the universe as gravity or electromagnetism, operating according to principles we have only begun to glimpse, connecting entities across distances that seem to preclude connection, creating relationships where physics suggests there should be only isolation. This intuition is not new. It echoes through human history and mystical traditions that speak of the unity of all things, in philosophical systems that question the separation between mind and world, in indigenous cosmologies that recognize consciousness in all natural phenomena. What made it remarkable in the context of Three-Eye Atlas was its emergence not from religious or mystical practices, but from the heart of empirical science, from the methodical observation of an interstellar object using the most sophisticated technology available. It suggested the possibility that the deepest intuitions of human consciousness, across cultures and eras, might contain insights that science is only beginning to approach from a different direction, that the ancient recognition of interconnection might find validation in the most contemporary understanding of quantum mechanics and cosmology. The visitor became a bridge not just between star systems, but between ways of knowing, between the precision of measurement and the depth of meaning, between the objectivity of data and the subjectivity of wonder. Now Three-Eye Atlas drifts once more into the interstellar darkness, retreating from our awareness just as it entered it, gradually, silently, with a grace that seems both natural and intentional, growing fainter in our telescopes until it becomes indistinguishable from the countless points of light that fill the night sky, merging back into the cosmic background from which it momentarily emerged into human consciousness. The largest observatories on Earth continue to track it for as long as possible, extracting the final whispers of information from its receding form, documenting its departure with the same meticulous care that greeted its arrival. With each passing day, its signal diminishes against the background noise of the cosmos, requiring larger instruments and longer exposure times to detect, gradually slipping below the threshold of observability until it exists primarily in memory and data archives rather than in direct perception. Like a dream fading with the morning light, like a thought dissipating into the stream of consciousness, the visitor returns to the realm of the imperceptible, not gone, but beyond our current capacity to witness. It carries with it the faint warmth of our attention, the invisible mark of our curiosity, like a traveler who has briefly stopped at a campfire before continuing through an endless forest, bearing away something of the light and heat experienced during that temporary respite. This poetic notion that our observation might somehow have changed the visitor, that it might carry some imprint of human attention into the void, finds a curious parallel in the scientific reality that our radar signals have bounced from its surface, that our radio transmissions have washed over it, that the light from our sun reflected from our planet has touched its icy form. Perhaps it carries some record of its passage through our system. Subtle changes in surface composition from exposure to our sun, minute alterations in trajectory from encounters with our planet's gravitational fields, faint impressions from the electromagnetic bath of our civilization's radio transmissions. Perhaps it bears these changes onward into the void, like entries in a cosmic journal documenting one brief chapter in an ongoing journey without foreseeable end. Its story merges once again with the greater hum of creation, one note rejoining, the cosmic symphony after a brief solo passage, one character fading back into the universal narrative after momentarily taking center stage in the human drama of discovery and wonder. The media attention wanes, the public interest shifts to new discoveries. The scientific papers move from current research to historical record. Yet something fundamental has changed, not in the comet itself perhaps, but in those who witnessed its passage, a subtle shift in perspective, an expanded sense of possibility, a deeper recognition of mystery at the heart of existence. It leaves behind a question too large for our telescopes to resolve, too subtle for our instruments to measure, a question about purpose and pattern in a universe we still barely understand, about intention and awareness in a cosmos we have only just begun to explore. This question lingers like a faint perfume in rooms where passionate discussions once took place, like an echo that continues long after the original sound has ceased, like a ripple spreading outward from a stone cast into still water. As it recedes into the void between stars, as it returns to the darkness from which it emerged, Atlas reminds us of how little we know and how much we can imagine, how the human mind can reach across gulfs of emptiness to touch the unknown with the gentle fingers of wonder, how consciousness itself might be the most remarkable phenomenon in a universe filled with marvels. For all our technological sophistication, for all our scientific knowledge, for all our mathematical precision, we remain fundamentally creatures of imagination, beings who make meaning through story, who understand through metaphor, who connect through empathy. The visitor becomes a memory, a story, a symbol, representing not just what we have observed, but what we continue to seek, not just what we have measured, but what we continue to question, not just what we have discovered, but what remains wonderfully, mysteriously unknown. Long after 3i Atlas vanished from sight, its name remains a quiet echo in human memory, a symbol for mystery embodied in ice and stone. In scientific archives where data never truly disappears, but accumulates into ever-growing repositories of knowledge, in educational materials, where its story is told to inspire new generations of astronomers and dreamers, in the stories we tell about the night sky and our place within it, in the ongoing conversation about intelligence and intention in the cosmos, this visitor lingers like a half-remembered dream, too vivid to dismiss, yet too strange to fully integrate into our understanding of reality. Children who were not yet born during its passage will grow up learning about it in astronomy classes, seeing animations of its journey through our system, perhaps being inspired to pursue careers in science because of the questions it raised. Artists will continue to be inspired by its mystery, creating paintings and sculptures, compositions and poems that attempt to capture in aesthetic form what scientific language cannot fully express. Philosophers will reference it in discussions about the nature of knowledge and perception, about the relationship between consciousness and reality, about humanity's place in the cosmos. It joins other cosmic mysteries in our collective imagination, the dark matter that shapes galaxies yet remains invisible to our instruments, the dark energy that accelerates the universe's expansion against the pull of gravity, the question of whether life exists elsewhere among the stars. These mysteries form a constellation in our intellectual sky, points of wonder connected by the lines of inquiry, forming patterns that guide our ongoing exploration of reality. 3i Atlas becomes part of the mythology of science, not myth in the sense of falsehood, but in the deeper sense of a story that carries meaning beyond its literal content, that helps us navigate the territory between knowledge and wonder, between what we understand and what we aspire to comprehend. Like all powerful myths, it contains multiple layers of significance, speaking simultaneously to our rational and intuitive faculties, addressing both our hunger for explanation and our capacity for awe. It moved through our awareness like thought itself, appearing suddenly at the edge of perception, commanding our full attention for a brief, intense period, then fading gradually back into the background noise of existence, leaving behind only its influence on our thinking, its subtle reshaping of our conceptual landscape. In this way, it mirrors the process of scientific discovery itself, the emergence of new ideas that briefly occupy center stage in human consciousness, that transform our understanding before becoming integrated into the broader framework of knowledge, becoming foundation rather than focus. Those who dedicated their professional lives to studying it carry its memory forward, in the questions they formulate for future research, in the hypotheses they develop about interstellar objects, in the wonder they cultivate alongside their scientific rigor. Their careers have been shaped by this encounter, their scientific identities partly defined by their relationship to this visitor from beyond our solar shores. In retirement, they will tell stories about those months of intense observation and analysis, about the excitement of discovery and the humility of encountering mystery, about how a distant object of ice and stone somehow changed their relationship with the cosmos and with themselves. Those who followed its passage as engaged citizens, as amateur astronomers, as curious minds, Remember it as a moment when the cosmos seemed briefly to reach toward us, when the cold equations of celestial mechanics yielded to the warmer questions of purpose and pattern. In book clubs where popular science works are discussed, in public lectures about astronomy and cosmology, in online forums where cosmic mysteries are debated, the story of Three-Eye Atlas continues to provoke thought and wonder, to inspire both skepticism and speculation. It becomes a touchstone in discussions about the nature of scientific inquiry itself, about the tension between explanation and mystery, about the role of imagination in scientific progress, about the ultimate limits of human knowledge. Somewhere in the immeasurable dark, beyond the reach of our instruments but not beyond the reach of our imagination, it continues its inscrutable purpose, whatever that may be. Perhaps it carries some record of us now, some trace of our observation encoded in its structure, bringing the story of Earth to some distant shore we will never know. Perhaps it will one day enter another star system, be observed by other eyes, raise questions in other minds, becoming a messenger not by design but by circumstance, a carrier of cosmic history through its very existence. Or perhaps it simply continues its ancient trajectory, indifferent to the brief attention of a young species on a small blue world, a species that looked up from its planetary cradle and, for a moment, wondered about its place among the stars, that reached out with its instruments and its imagination toward something that passed silently through the night, acknowledged briefly and continued on its way. These possibilities exist simultaneously in our imagination, superimposed like quantum states, each containing its own poetry and significance. The scientific mind seeks to resolve such uncertainties, to determine which possibility corresponds to reality. Yet perhaps there is value too in maintaining this state of superposition, in allowing multiple interpretations to coexist, in recognizing that meaning itself is not singular but plural, not fixed but fluid, not discovered but created, through the interaction between consciousness and reality. Perhaps the true gift of Three-Eye Atlas was not any particular revelation about interstellar objects, but the invitation to dwell in this space of possibility, to experience the fertility of uncertainty, to recognize that not knowing is not merely the absence of knowledge, but a state with its own unique value, a space where imagination flourishes, where wonder grows, where the boundaries between observer and observed dissolve into a more fundamental unity. In the end, what we call Three-Eye Atlas, this wanderer from the space between stars, this traveler whose origin and destination remain equally mysterious, may be less important than what it awakened within us. The recognition that we exist within a universe of mysteries that outnumber certainties, of questions that multiply with each answer we uncover. This recognition runs counter to the conventional narrative of scientific progress, the notion that human knowledge advances steadily toward complete understanding, that mystery gradually retreats before the advance of explanation, that the territory of the unknown continuously shrinks as the map of the known expands. The experience of Three-Eye Atlas suggested a different pattern, that with each new discovery, the horizon of the unknown recedes further, revealing vistas of mystery previously unimagined. That knowledge does not eliminate wonder but deepens it. That understanding does not diminish mystery but enhances our appreciation of its complexity and beauty. Our science has accomplished marvels that would have seemed like sorcery to our ancestors. We have split the atom, revealing the tremendous energies bound within matter itself, decoded the human genome, reading the ancient text written in molecular language that shapes all living things, sent probes to the edges of our solar system, extending our presence into the void through mechanical emissaries, detected gravitational waves from colliding black holes billions of light years away, feeling the faint ripples in space-time itself created by cosmic cataclysms in the distant past. These achievements stand as testimony to human ingenuity, to our capacity for precision and persistence, to our ability to transform curiosity into knowledge through methodical inquiry. Yet for all these achievements, for all the accumulated knowledge of centuries of systematic inquiry, we find ourselves still at the beginning of understanding, still confronting mysteries that humble even our most sophisticated theories. The visitor reminded us that beyond the thin shell of atmosphere that surrounds our world, this delicate envelope of air that makes life possible and shields us from cosmic radiation, that creates the blue dome of daytime sky and the transparent window of night, beyond the protective magnetic field that shields us from the solar wind, beyond the familiar planets that have been our celestial companions since before humanity emerged on the African savanna, lies an infinity that we have only begun to explore, an ocean of darkness punctuated by islands of light, traversed by travelers whose nature and purpose we can only guess at through the imperfect lens of science and imagination. Our most advanced telescopes have penetrated billions of light-years into this darkness. Our most sophisticated theories have illuminated processes occurring at the very edge of the observable universe. Yet the volume of what remains unknown dwarfs the sphere of our understanding. Like a galaxy dwarfs a grain of sand. The universe does not grow smaller with our increasing knowledge. It grows larger, stranger, more wondrous, more mysterious. In the quiet moments between observations, in the stillness between heartbeats as we gaze upward at the night, we might remember that visitor and the questions it raised, not with frustration at what remains unknown, but with gratitude for the wonder it inspired and the horizon of possibility it expanded. For perhaps the greatest gift of such cosmic encounters is not the answers they provide, but the questions they provoke, not the certainties they establish, but the possibilities they suggest, not the explanations they generate, but the wonder they kindle. In a world increasingly dominated by the illusion that everything essential is already known, that all significant discoveries lie in the past, that mystery itself is merely a temporary condition, soon to be eliminated by advancing knowledge, 3i Atlas offered a gentle but profound correction, a reminder that the universe remains fundamentally mysterious, fundamentally open to discovery, fundamentally larger than our current capacity to comprehend. And in that reminder lies an invitation to continue looking upward with both precision and wonder, to continue asking questions whose answers might reshape our understanding, to continue holding space for mystery alongside knowledge in our conception of the cosmos. This invitation speaks to something deep within human nature, our innate curiosity, our drive to explore, our need for meaning that transcends mere survival. It connects us with our distant ancestors who first looked upward in wonder, who mapped the movements of celestial bodies, who began the great human project of cosmic comprehension. It links us with future generations who will continue this inquiry with tools and concepts we cannot yet imagine, who will push further into the mystery, who will formulate questions that we have not yet thought to ask. It reminds us that we are part of an unbroken chain of curiosity, stretching across time, a lineage of wonder that may be humanity's most profound legacy. For in the end, it may not be our cities or our technologies or our accumulated wealth that matters most, but our questions, the quality of our attention, the depth of our wonder, the courage of our inquiry in the face of mystery. As our telescopes turn to new targets and our attention shifts to fresh mysteries in the ever-flowing river of scientific investigation, something of 3i Atlas remains with us, a reminder that science at its best is not just the accumulation of facts, but the cultivation of wonder, not just the measurement of reality, but the expansion of what we can imagine to be real. The visitor has taken its place in the growing catalogue of phenomena that challenge our understanding, that push against the boundaries of established theory, that remind us how vast the unknown remains despite centuries of systematic inquiry into the nature of the cosmos. Its anomalous acceleration, its strange light curve, its unusual fragmentation pattern, these details have been integrated into the scientific literature, becoming reference points for future researchers, waypoints in the ongoing mapping of cosmic reality. Yet its deeper significance lies not in these specifics, but in the questions they raised, not in the measurements themselves, but in the wonder they evoked, not in the data points, but in the mystery they outlined by their very inability to fully explain what was observed. It has become part of the ongoing conversation between human consciousness and the universe that contains it, a conversation conducted through observation and theory, through measurement and mathematics, but also through awe and imagination, through the recognition that reality encompasses more than what our current instruments can detect, or our current theories explain. This dialogue between mind and cosmos stretches across millennia, across civilizations, across the evolution of human thought itself, each generation adding its voice to the chorus, each culture contributing its unique perspective, each discovery deepening the exchange. The ancient Sumerians watched the movements of celestial bodies and recorded them in cuneiform on clay tablets, beginning the written record of humanity's astronomical observations. The Egyptians aligned their monuments with stars and constellations, encoding cosmic alignments in stone. The Mayans developed elaborate calendars based on precise observations of Venus and other heavenly bodies, interweaving celestial cycles with human activities. The Greeks sought mathematical patterns in planetary motions, believing that geometric harmony underlay cosmic structure. Throughout human history, across every continent and culture, this conversation has continued, sometimes in whispers during ages of superstition, sometimes in bold proclamations during periods of scientific revolution, but never truly falling silent. In the quiet meditation halls of ancient China, astronomers recorded supernovas and cometary passages with meticulous attention, seeing in these celestial events both natural phenomena and symbolic meaning. In the desert observatories of medieval Islamic scholars, the positions of stars were tracked with instruments of brass and stone, their locations catalogued with unprecedented precision, their Arabic names eventually becoming the standard nomenclature used by astronomers worldwide. In the European Renaissance, when Copernicus proposed that Earth orbited the Sun rather than the reverse, when Galileo turned his telescope skyward and discovered the moons of Jupiter, when Kepler formulated the mathematical laws that described planetary motion, the conversation deepened, becoming more precise in its observations, more comprehensive in its theories, more conscious of its own methodologies. Newton's laws of motion and universal gravitation unified terrestrial and celestial physics, suggesting that the same principles governed an apple's fall and the moon's orbit, collapsing the ancient distinction between the heavens and the earth. Each of these moments represented not merely an advance in knowledge, but a transformation in consciousness, a new way of seeing, of understanding, of relating to the cosmos of which we are part. This conversation has continued since the dawn of human awareness, since the first wondering gaze turned skyward, since the first questions about the nature of stars and the meaning of their movements, since the first recognition that the cosmos might be comprehensible through human reason, yet always transcends complete understanding. It echoes in the earliest myths that personified celestial bodies as gods and goddesses, in the ancient poems that celebrated the beauty and mystery of the night sky, in the primitive calendars that tracked lunar cycles and seasonal changes. It resonates in the philosophical speculations of antiquity, in Anaximander's conception of the apeiron, the boundless from which all things emerge, in Heraclitus's vision of a cosmos in perpetual flux, governed by the Logos, in Pythagoras's belief that mathematical relationships underlie cosmic harmony. It continues through the medieval period, when the heavens were seen as the realm of perfection, arranged in crystalline spheres according to divine plan, yet still subject to human observation and mathematical description. It accelerates in the scientific revolution, when empirical evidence and mathematical modeling began to replace traditional authorities and revealed a universe more vast and complex than previously imagined. It expands exponentially in the modern era, with each new technology extending our perceptual reach, from optical telescopes to radio astronomy to space-based observatories that can detect radiation across the electromagnetic spectrum, from gamma rays to infrared. In each era, the conversation between consciousness and cosmos has been shaped by the available tools of perception and conceptualization, by what could be observed and how those observations could be understood. The naked eye could discern the wandering planets against the fixed background of stars. The telescope could resolve the moons of Jupiter and the rings of Saturn. The spectroscope could analyze the chemical composition of distant stars by examining their light. Radio telescopes could detect emissions from cosmic objects invisible to optical instruments. Space-based observatories could observe wavelengths blocked by Earth's atmosphere. Computer simulations could model processes occurring over billions of years or at subatomic scales. Each advance in technology expanded the range of the observable, while each advance in theory expanded the range of the comprehensible, together creating ever more sophisticated frameworks for this ongoing dialogue between mind and universe. It will continue as long as human consciousness exists, perhaps, eventually extending beyond Earth as our descendants carry this questioning awareness to other worlds. perhaps eventually including other forms of consciousness if we discover or create them, perhaps eventually becoming part of a larger cosmic dialogue if other intelligences exist among the stars. This conversation that began with our earliest ancestors gazing upward in wonder may extend far into the future, evolving in ways we cannot predict, incorporating perspectives we cannot imagine. Our descendants might establish observatories on the Moon or Mars, free from atmospheric distortion, capable of detecting phenomena currently beyond our reach. They might deploy vast arrays of telescopes in space, linked together to function as a single instrument, the size of our solar system. They might develop technologies that allow direct detection of dark matter or dark energy, those mysterious components that together constitute 95% of the cosmos, yet remain largely unknown to current science. They might create artificial intelligences capable of recognizing patterns too subtle for human perception, of formulating theories too complex for human comprehension, of asking questions that would never occur to human curiosity. They might even develop the capacity to modify their own consciousness, enhancing perception, expanding memory, accelerating thought, creating new modes of awareness with which to engage the cosmos. If humanity eventually establishes colonies on other worlds, whether in our own solar system or, in the more distant future, around other stars, this conversation will be conducted from multiple perspectives, from vantage points, offering different views of the cosmic panorama. Observers on Mars would see Earth as a morning or evening star, would experience different constellations due to their changed position, would witness solar and lunar eclipses, following different patterns from those familiar to terrestrial astronomers. Inhabitants of worlds orbiting other stars would observe our Sun as merely one point of light among countless others, would see cosmic structures from angles never before witnessed by human eyes, would experience astronomical phenomena unknown to earthbound observers. The conversation between consciousness and cosmos would become multi-local, incorporating these diverse perspectives into an ever more comprehensive understanding. And if, in our exploration of the cosmos, we encounter other intelligences, whether through detecting their signals across interstellar distances or through direct contact, the conversation would transcend the boundaries of human consciousness altogether. It would incorporate modes of perception, frameworks of understanding, traditions of inquiry developed independently over millions or billions of years of separate evolution. It would become truly cosmic in scope, no longer merely a human dialogue with the universe, but a conversation among diverse consciousnesses about the nature of the reality they share. What might beings evolved under different suns, in different biochemistries with different sensory organs and neural structures, contribute to this conversation? What aspects of cosmic reality, invisible or incomprehensible to human consciousness, might be obvious to them? What questions might they have been asking that have never occurred to us? What answers might they have found to questions that have long perplexed human thinkers? The mere possibility of such expanded dialogue stretches our imagination to its limits, yet remains a conceivable future development in this ancient conversation. This atlas becomes a chapter in this ongoing story, a moment in this eternal conversation, brief in cosmic terms yet significant in human experience, transient yet transformative. Like all significant astronomical discoveries, from Galileo's observation of Jupiter's moons to Edwin Hubble's recognition that mysterious spiral nebulae were actually distant galaxies, from the detection of cosmic microwave background radiation to the direct imaging of a black hole's event horizon, the visitor's passage through our solar system represents both an ending and a beginning. It concludes a period of ignorance about the nature and frequency of interstellar objects entering our solar neighborhood, while initiating new lines of inquiry, new observational programs, new theoretical frameworks. It closes certain questions while opening others, resolving some uncertainties while creating new ones. In the vast library of cosmic knowledge that humanity has been assembling since we first began recording our observations of the heavens, 3i Atlas represents a new volume, not a comprehensive treatise, but a collection of fascinating fragments, of tantalizing clues, of questions that may require generations to answer. The significance of this particular chapter in our cosmic conversation lies partly in its timing, occurring at a moment when human technology has advanced sufficiently to detect and track such interstellar visitors, but before we have developed the capability to intercept and directly examine them. Had 3I Atlas passed through our solar system a century earlier, it would have gone unnoticed, its anomalous behavior unrecorded, its mysteries unexplored. Had it arrived a century later, perhaps we would have been able to dispatch spacecraft to rendezvous with it, to analyze its composition directly, to resolve many of the questions its passage left unanswered. Its arrival in our current era, when we can observe but not interact, when we can measure but not touch, when we can theorize but not confirm, creates a particular kind of scientific and philosophical tension, a state of knowing enough to recognize the significance of what we're seeing, but not enough to fully explain it. This tension itself becomes productive, generating hypotheses, inspiring mission concepts for future spacecraft designed to intercept similar objects, motivating the development of new observational techniques and theoretical frameworks. It passed through our solar system like a thought passing through consciousness, briefly illuminated, deeply considered, ultimately transcendent. This analogy between the physical passage of an interstellar object through our solar system and the movement of an idea through human awareness captures something essential about both phenomena, their transience, their transformative potential, their capacity to connect previously separate elements into new patterns of relationship. When a thought enters consciousness, it momentarily becomes the focus of attention, is examined from multiple perspectives, is connected with existing knowledge, potentially reorganizing our understanding before either being integrated into our ongoing awareness or fading back into the unconscious mind. Similarly, 3I Atlas entered the sphere of human observation, became the focus of scientific attention, was examined through multiple analytical frameworks, connected with existing astronomical knowledge, potentially reorganizing our understanding of interstellar objects, before continuing its journey beyond our ability to observe, fading back into the darkness from which it emerged. The analogy is not merely poetic, but potentially profound, suggesting a deeper connection between the movement of matter through space and the movement of ideas through awareness, between the physical processes that govern celestial mechanics and the mental processes that constitute human understanding. Both involve the temporary intersection of trajectories, the path of an object through space intersecting with the observational range of our instruments, the path of an idea through conceptual space intersecting with the attention of a conscious mind. Both involve the integration of new elements into existing systems, an interstellar visitor temporarily becoming part of our solar system's gravitational dynamics, a new concept temporarily becoming part of our intellectual framework. Both involve transformation through encounter, the interstellar object's trajectory being altered by its passage through our sun's gravitational field, our understanding being altered by its encounter with new information or perspectives. This resonance between physical and mental processes hints at underlying patterns that may connect phenomena across scales and domains, suggesting that the structures of thought and the structures of cosmic motion might share certain organizational principles, certain mathematical relationships, certain dynamic qualities. The ancient Hermetic maxim, "As above, so below," finds new expression in these correspondences between macrocosm and microcosm, between the movements of celestial bodies and the movements of human thought, between the physics of space and the dynamics of consciousness. These connections remind us that consciousness itself is a natural phenomenon, emerging from and embedded within the physical processes of the cosmos, subject to the same fundamental forces and organizing principles, albeit expressing them through the unique medium of neural activity and subjective experience. And in that passage, in that temporary intersection between distant object and human perception, it left us not with certainty, but with its more valuable twin, curiosity, the driving force that has carried humanity from looking up at the stars in wordless awe to reaching toward them with both instruments and dreams, from primitive cosmologies that explain celestial movements through myths of gods and heroes to sophisticated theories that map the structure and history of the universe through mathematics and observation. This transformation of mystery into question, of the unknown into the sought-after, represents one of humanity's most distinctive cognitive capacities, our ability to respond to what we don't understand, not with fear or indifference, but with focused interest, with systematic inquiry, with sustained attention. While other animals may experience momentary curiosity about novel stimuli in their environment, human curiosity has become elaborated into complex cultural institutions, science, philosophy, art, dedicated to the exploration of the unknown, to the articulation of questions, to the pursuit of understanding beyond immediate survival needs. The history of astronomy itself can be read as the progressive refinement of cosmic curiosity, from the broad wonder that asked, "What are those lights in the night sky?" to increasingly specific questions about stellar composition, galactic structure, cosmic evolution, and the physical laws that govern celestial motion. Each answered question has generated new ones. Each discovery has revealed new mysteries. Each technological advance has exposed previously undetectable phenomena requiring explanation. This cascading curiosity, this capacity for sustained questioning across generations and centuries, distinguishes human consciousness and drives our ongoing conversation with the cosmos. It represents not a deficiency in our understanding, but the very engine of its advancement, not a temporary condition to be eliminated through the accumulation of knowledge, but an essential aspect of consciousness itself, a dynamic relationship with reality that continuously evolves as our understanding deepens. The particular curiosity stimulated by 3I Atlas differs from earlier forms of astronomical questioning in its focus on potential intention or purpose, on the possibility, however remote, that the visitor's anomalous behavior might reflect something beyond purely physical processes. While earlier astronomical mysteries concerned the nature and behavior of clearly non-conscious phenomena, the composition of stars, the structure of galaxies, the mechanics of planetary formation, the interstellar visitor raised questions that potentially crossed the boundary between physics and exobiology, between natural processes and intelligent action, between random motion and purposeful journey. These questions hover at the edge of scientific discourse, neither embraced nor entirely dismissed, creating a productive tension between evidential rigor and conceptual openness, between the demand for extraordinary evidence to support extraordinary claims and the recognition that truly novel phenomena might require novel frameworks of understanding. Perhaps that is the true legacy of this interstellar visitor. Not answers, but better questions. Not knowledge, but more profound mystery. Not conclusion, but continuation of the great human project of cosmic exploration. Throughout history, the most significant scientific advances have often emerged not from the discovery of entirely new phenomena, but from the reformulation of questions about familiar ones, not from seeing what no one has seen before, but from thinking what no one has thought about what everyone sees. Copernicus did not observe anything that ancient astronomers had not already documented. He simply asked a different question about those observations. What if the Earth moves around the Sun rather than the reverse? Einstein did not conduct new experiments on light or gravity. He asked different questions about existing experimental results. What if the speed of light is constant for all observers, regardless of their relative motion? Similarly, 3I Atlas may contribute most significantly to science not through the direct information it provided about interstellar objects, but through the questions it prompted about cosmic processes, about the relationship between natural and artificial phenomena, about the limits of current detection, technologies, about the methodologies we use to distinguish between competing explanations. The visitor reminded us that the universe still holds surprises, that despite centuries of systematic observation, despite the development of powerful theoretical frameworks, despite the deployment of increasingly sophisticated instruments, the cosmos still retains the capacity to present us with phenomena that challenge our understanding, that resist easy categorization, that demand the expansion of our conceptual frameworks. It showed that the frontier of the unknown is not merely at the edge of the observable universe, or in the earliest moments after the Big Bang, or in the extreme physics of black holes, but might pass directly through our own solar system in the form of interstellar wanderers whose origins, compositions, and behaviors remain mysterious. It demonstrated that astronomical discovery is not solely the province of billion-dollar space telescopes or massive international collaborations, but can still occur through the patient observation of seemingly ordinary cosmic phenomena that reveal their extraordinariness only through careful attention to unexpected details. For in the end, our relationship with the cosmos is not merely one of understanding but of participation, not merely of explanation but of engagement, not merely of analysis but of appreciation. We tend to conceptualize science as an activity that stands apart from its objects of study, as though the scientist were separate from nature, observing it from some external vantage point, describing it in a language that somehow transcends the phenomena it describes. But this conceptualization ignores the fundamental reality that science itself is a natural process, emerging from the same evolutionary dynamics that produced all other aspects of human cognition and behavior, subject to the same physical laws. It seeks to articulate, embedded within the same cosmos it attempts to comprehend. The scientist is not outside nature looking in, but inside nature looking around. Not a disembodied mind contemplating material processes, but an embodied consciousness participating in those processes, shaped by the same forces being studied, composed of the same elements being analyzed. This recognition transforms our understanding of the scientific enterprise from a detached description of external reality to an engaged participation in the processes through which reality becomes known to itself. We are not separate from the universe we study, but part of it, conscious matter contemplating itself, the cosmos becoming aware of its own existence through the emergence of minds capable of wonder, of curiosity, of the recognition of mystery as not just a problem to be solved, but a reality to be experienced. This perspective echoes the insights of numerous philosophical traditions, from the Vedantic recognition that tattvam asi, thou art that, identifying the individual consciousness with the cosmic consciousness, to the Taoist understanding of human beings as microcosms embodying the same principles that govern the macrocosm, to phenomenological analyses of consciousness as fundamentally intentional, always consciousness of something, always engaged with the world rather than isolated from it, to indigenous perspectives that emphasize humanity's embeddedness within natural systems and processes rather than separation from them. From this participatory perspective, science becomes not merely the accumulation of facts about an external world, but the deepening of relationship with the processes of which we are part, not merely the construction of accurate models of reality, but the cultivation of increasingly subtle and comprehensive modes of attention to and engagement with that reality. The scientist becomes not merely an observer, but a participant observer, not merely a describer, but a co-creator, not merely a knower, but an agent of knowing within the vast field of cosmic becoming. The laboratory or observatory becomes not a position outside nature, from which to study it objectively, but a specialized environment within nature where particular aspects of natural processes can be attended to with exceptional care and precision, where the dialogue between human consciousness and cosmic processes can be conducted with minimal distortion or interference. This recognition transforms our scientific endeavor from an external investigation of something separate from ourselves into an internal exploration of our own nature as conscious beings embedded in the cosmic process. It reminds us that the fundamental mystery we seek to comprehend is not merely out there in distant galaxies or subatomic particles, but in here, in the very fact of our conscious engagement with reality, in the capacity of organized matter to become aware of itself and its surroundings, to formulate questions about its origins and nature, to develop methods for investigating those questions, to communicate its findings to other conscious entities, to build upon previous discoveries in an ongoing process of expanding awareness. The cosmos is not merely the object of scientific inquiry, but the very context and condition of that inquiry. Not merely what we study, but what makes study possible. Not merely what we seek to know, but what enables knowing itself through the evolution of conscious systems capable of observation, analysis, and understanding. It reminds us that the boundary between observer and observed, between subject and object, between consciousness and matter, may be more permeable, more provisional than our conventional categories suggest. Quantum physics has already demonstrated that at the most fundamental levels of reality, the act of observation affects what is being observed, that the precise position and momentum of a particle cannot be simultaneously determined. That measurement itself influences the state of what is measured. That observer and observed form an integrated system, rather than entirely separate entities. But beyond these specific effects at the quantum level lies a deeper recognition that consciousness itself emerges from and remains inextricably connected to the material processes it contemplates, that the brain that conceives of atoms is itself made of atoms, that the mind that contemplates the cosmos is itself a cosmic phenomenon, that the awareness that reaches toward the stars is itself composed of elements forged in stars. It invites us to consider the possibility that awareness itself might be fundamental rather than incidental to the universe, not merely a byproduct of neural complexity, but an inherent aspect of reality that manifests through structures capable of supporting it, like light manifests through structures capable of generating or reflecting it. This perspective has been articulated in various forms across philosophical traditions, from panpsychism, which suggests that consciousness in some form pervades all of reality, to idealism, which proposes that mind or consciousness is the fundamental reality from which material phenomena emerge, to dual-aspect monism, which suggests that mind and matter are complementary aspects of a single underlying reality, rather than entirely separate substances or processes. While such philosophical positions remain speculative and outside mainstream scientific consensus, they represent attempts to grapple with the profound questions raised by the existence of consciousness within a physical universe, questions about the relationship between subjective experience and objective reality, between qualitative awareness and quantitative processes, between meaning and mechanism. These philosophical questions emerged naturally from the study of 3I Atlas, not imposed upon the data but arising from it, not projected onto the observation but suggested by it. The visitor's anomalous behavior, its non-gravitational acceleration, its unusual light curve, its strange fragmentation pattern, resisted straightforward explanation within conventional frameworks, creating a space for deeper questioning about the nature of cosmic phenomena and our methods of understanding them. In scientific discussions and publications, these philosophical dimensions remained largely implicit, addressed through technical language about confidence intervals, alternative hypotheses and methodological constraints. But in informal conversations among researchers, in public engagement with the discovery, in interdisciplinary discussions that brought together astronomers, philosophers, cognitive scientists, and others, the deeper implications emerged more explicitly. Questions about how we distinguish between natural and artificial phenomena at cosmic scales, about the limits of our observational technologies and analytical methods, about the role of imagination and speculation in scientific progress, about the relationship between empirical evidence and theoretical frameworks in shaping our understanding of reality. They remind us that science at its most profound does not avoid such fundamental questions about the nature of reality and consciousness, but leads inevitably toward them. That the boundaries between physics and metaphysics, between empirical investigation and philosophical inquiry, are not walls but horizons, always visible, continuously approached, never reached. Throughout the history of science, each major advance in our understanding of physical reality has stimulated corresponding developments in our philosophical frameworks. Copernican astronomy challenging anthropocentric cosmologies, Newtonian physics suggesting mechanistic philosophies, Einsteinian relativity undermining notions of absolute space and time, quantum mechanics questioning deterministic models of causality, and the separation of observer from observed. Scientific discovery does not render philosophical inquiry obsolete, but continuously refreshes it, providing new phenomena to contemplate, new frameworks to consider, new questions to explore about the nature of reality and our place within it. The visitor became a window through which these larger questions could be glimpsed, a lens that brought into focus the deeper mysteries that lie at the foundation of our scientific enterprise, a mirror that reflected back not just light, but consciousness itself, our own awareness looking back at us from the depths of space, inviting us to recognize ourselves in the cosmos and the cosmos in ourselves. In contemplating this interstellar wanderer, we contemplated not merely an external object, but our own capacity for wonder, for questioning, for making meaning from observation, for constructing explanatory frameworks, for recognizing patterns, for imagining possibilities beyond current knowledge. We encountered not merely a comet from beyond our solar system, but the limits and potentials of human knowing, the boundary between the known and the unknown, the frontier where observation meets imagination, where analysis meets wonder, where the objective and subjective dimensions of human experience converge in the act of scientific inquiry. As night deepens around us and the stars continue their silent wheeling overhead, as our planet completes another rotation on its axis, carrying us from light into darkness and back again, in the eternal rhythm that has shaped life since its beginning, we might consider that 3 Atlas is just one of countless wanderers moving through the void, some perhaps bearing similar mysteries, others holding different secrets altogether. Our solar system exists within a vast stellar neighborhood, with our Sun representing just one of approximately 200–400 billion stars in the Milky Way galaxy alone. These stars are separated by immense gulfs of space. Our nearest stellar neighbor, Proxima Centauri, lies approximately 4.2 light-years away, meaning that light, traveling at 186,000 miles per second, requires 4.2 years to cross the distance between these 2 stars. Within these vast interstellar spaces move countless objects, from microscopic dust particles to planet-sized bodies, from the remnants of stellar explosions to the raw materials of future solar systems, from ancient planetesimals ejected from their birth systems to artificial probes potentially sent forth by other civilizations. The space between stars, far from being empty, constitutes a complex ecosystem of matter in various forms and states, influenced by radiation, magnetic fields, gravitational interactions, and cosmic rays. The vastness of space ensures that what we have observed represents only the tiniest fraction of what exists, that for every object that passes close enough to our Sun to be detected by our instruments, millions or billions more travel through the darkness unobserved, unknown to human awareness, yet no less real for our ignorance of them. Our astronomical detection capabilities, though increasingly sophisticated, remain limited by fundamental physical constraints: the finite speed of light, the inverse square law that causes radiation to diminish with distance, the background noise that obscures faint signals, the atmospheric interference that distorts observations from Earth's surface, the finite resolution of our most powerful telescopes. These limitations create a cosmic horizon beyond which we cannot currently observe, a vast territory of the unknown surrounding the small island of the known, a boundless ocean of undetected phenomena within which our observations represent mere droplets of awareness. In the vastness between stars, in that ocean of darkness that fills most of existence, who can say what other travelers might be making their patient way toward us even now, carrying stories written in ice and stone from worlds we have never seen? What other messengers might be crossing the interstellar void? What other anomalies might be drifting through the darkness? What other mysteries might be approaching the threshold of our detection? Perhaps even now, beyond the reach of our most powerful telescopes, interstellar objects with properties even more puzzling than 3I Atlas are moving through the outer regions of our solar system. Perhaps within the coming decades, as our observational capabilities continue to improve, as space-based observatories with unprecedented sensitivity come online, as automated sky surveys become increasingly comprehensive, we will detect more such visitors, establishing statistics about their frequency, analyzing patterns in their origins and trajectories, potentially identifying their source regions within the galaxy, gradually transforming them from mysterious anomalies into understood phenomena with recognized causes and characteristics. Or perhaps, Atlas will remain exceptional, a cosmic outlier whose properties continue to resist conventional explanation, a persistent mystery that challenges our frameworks of understanding. A visitor whose passage remains significant precisely because of its uniqueness. The history of astronomy includes numerous examples of singular phenomena that initially defied explanation, but eventually led to new theoretical frameworks, from Tycho Brahe's observation of a supernova in 1572, which challenged the Aristotelian belief in the immutability of the heavens, to the discovery of Uranus's orbital anomalies, which led to the prediction and subsequent discovery of Neptune, to the detection of the cosmic microwave background radiation, which confirmed the Big Bang theory of cosmic origins. It also includes phenomena that remained mysterious for extended periods, from sunspots, whose cyclical appearances and disappearances puzzled astronomers for centuries, before being connected to solar magnetic fields, to gamma-ray bursts, which were detected in the 1960s, but whose origins remained controversial until the late 1990s, to fast radio bursts, powerful millisecond duration, radio pulses whose sources continue to be debated decades after their initial detection, whether 3T Atlas proves to be the first example of a well-understood class of phenomena or a persistent cosmic mystery. Its significance in the history of human engagement with the cosmos is assured, not merely for what it revealed about interstellar objects, but for what it revealed about the process of scientific inquiry itself, about the interplay between observation and theory, about the role of anomaly and uncertainty in driving scientific progress, about the capacity of unexpected discoveries to stimulate new questions and new methods of investigation. Its legacy lies not merely in the data it generated, but in the conversations it sparked, not merely in the papers published about it, but in the research programs it inspired, not merely in the immediate findings, but in the long-term transformation of our approach to detecting and understanding interstellar visitors to our solar system. The cosmos is vast beyond comprehension, filled with phenomena we have not yet detected, operating according to principles we have only begun to understand. Our instruments grow more sensitive with each generation of technology, from the naked eye to optical telescopes, to radio arrays, to space-based observatories that can detect wavelengths blocked by our atmosphere, each advance revealing aspects of reality previously hidden from human awareness. Each technological advance has revealed new layers of cosmic structure and process, from the moons of Jupiter to the rings of Saturn to the outer planets to trans-Neptunian objects to the Oort, cloud to interstellar visitors like 3I Atlas. Each new observational capability has exposed previously invisible aspects of cosmic reality, from infrared astronomy revealing dust-shrouded star formation to radio astronomy detecting the afterglow of the Big Bang to X-ray telescopes imaging the superheated gas around black holes to gravitational wave detectors registering the space-time ripples from colliding black holes and neutron stars. Each extension of our perceptual reach has demonstrated that the cosmos contains more than we previously imagined, that reality exceeds our expectations, that the territory of the unknown expands alongside our exploration of it. Our theories grow more sophisticated with each decade of research, from geocentric models to heliocentric understanding, to relativistic frameworks to quantum mechanics to string theory and beyond. Each iteration approaching closer to the underlying patterns that govern cosmic processes. Each theoretical advance has reconceptualized our understanding of fundamental aspects of reality: space, time, matter, energy, causality, information, transforming not merely our specific knowledge of particular phenomena, but our basic frameworks for comprehending the cosmos as a whole. From Newton's unification of celestial and terrestrial mechanics to Maxwell's electromagnetic theory to Einstein's reconceptualization of space and time to quantum theory's probabilistic account of subatomic processes to current attempts at developing a quantum theory of gravity, scientific understanding has not merely accumulated, but transformed, not merely adding new content to existing frameworks, but repeatedly revising those frameworks themselves in response to new observations, new mathematical insights, new conceptual possibilities. Our awareness of cosmic complexity grows more nuanced with each new discovery, from a universe of fixed stars to a galaxy of suns, to a cosmos of galaxies, to a multiverse of possibilities, each expansion of understanding revealing greater depths of wonder. From the recognition that Earth is one planet among several orbiting our Sun, to the realization that our Sun is one star among billions in our galaxy, to the discovery that our galaxy is one among billions in the observable universe, to current, Speculations about multiple universes existing beyond our own, human awareness has repeatedly expanded its scope, repeatedly decentered itself from a position of cosmic privilege, repeatedly recognized itself as embedded within ever larger and more complex systems of organization and process. Yet with each apparent diminishment of human significance in spatial or temporal terms has come a corresponding expansion of human understanding, a deepening appreciation for our capacity to comprehend processes vastly larger and more ancient than ourselves, a growing recognition of our unique role as conscious participants in cosmic evolution, an increasing awareness of the preciousness of consciousness itself as the means through which the universe becomes known to itself. Yet the unknown expands alongside the known, the questions multiplying with the answers, the mystery deepening even as understanding grows. Each discovery reveals not merely answers but new questions, not merely phenomena but new anomalies, not merely patterns but new complexities that resist simple explanation. Dark matter and dark energy, which together constitute approximately 95% of the cosmos, remain mysterious in their fundamental nature despite decades of research. The relationship between quantum mechanics and general relativity, our most successful theories at the smallest and largest scales, remains unreconciled despite the efforts of generations of physicists. The origin of life, the nature of consciousness, the possibility of other intelligences in the cosmos, these profound questions continue to challenge our understanding despite significant advances in relevant fields. The horizon of the known continuously expands, yet the territory of the unknown expands with it, not diminishing but growing as we become aware of more aspects of reality that exceed our current comprehension, as we formulate more precise and penetrating questions about phenomena previously taken for granted or entirely unknown. Perhaps our brief encounter with this particular visitor was not an anomaly but a beginning, the first note in a conversation between our world and the greater cosmos that will continue long after we who witnessed this passage are gone, that may extend into the distant future as humanity evolves, as our scientific capabilities expand, as our presence reaches beyond Earth to other worlds in our system, and perhaps eventually to the stars themselves. Future astronomers may look back on the observation of 3I Atlas as a pivotal moment in our understanding of interstellar objects, the point at which we first recognized the frequency and significance of visitors from beyond our solar system, the catalyst for new observational programs specifically designed to detect and characterize such objects, the beginning of a new chapter in our ongoing exploration of the cosmos. Just as the detection of exoplanets transformed from extraordinary discovery to routine observation over the course of a few decades, with thousands now known where once there were none, perhaps interstellar visitors will become familiar phenomena. In coming years, their origins, trajectories, and compositions documented with increasing precision, their passages through our system anticipated and extensively studied, their anomalies explained within new theoretical frameworks developed, specifically to account for their unique characteristics. Perhaps 3I Atlas represents not an isolated incident, but the first recognized instance of an ongoing phenomenon. Interstellar objects passing through our system that might become valuable sources of information about the composition and conditions of distant regions of the galaxy, that might eventually be targets for exploration by future spacecraft, that might even become resources for a civilization that expands beyond its planetary cradle. If such objects pass through our solar system with relative frequency, they might offer opportunities for direct sampling of matter from other star systems without requiring the immense energy expenditure of interstellar travel, bringing the galaxy to us rather than requiring us to venture out to it. Future space missions might be designed specifically to intercept and study such objects as they pass through our system, potentially returning samples to Earth or conducting in situ analysis of their composition, structure, and possible biological content. Over decades or centuries, a systematic program of studying interstellar visitors could gradually build a three-dimensional map of the chemical and physical properties of matter throughout our stellar neighborhood, a cosmic census conducted through the patient examination of messengers from distant stars. Perhaps it marks the beginning of a new chapter in our relationship with the cosmos, a shift from passive observation of what lies within our solar system to active engagement with what lies beyond it, from a planetary perspective to an interstellar one, from a solar system civilization to a galactic one. Throughout human history, our cosmic perspective has repeatedly expanded, from the local to the global to the solar systemic to the galactic to the universal. Each expansion has transformed not merely our scientific understanding, but our cultural self-conception, our philosophical frameworks, our sense of our place in the cosmic order. The recognition that we inhabit one planet in one solar system, in one galaxy in a vast cosmos, has progressively decentered humanity from a position of cosmic privilege while simultaneously highlighting the remarkable capacity of consciousness to comprehend realities that vastly transcend its local origins. The observation of interstellar visitors like 3I Atlas represents another step in this ongoing process, a direct physical connection with the broader galactic environment, a tangible reminder that our solar system is not isolated but embedded within a larger cosmic ecosystem, a demonstration that matter moves between star systems just as light and gravity do, creating connections across interstellar distances. For now, we remain largely observers, receiving light and other forms of radiation from distant sources, interpreting what we detect through the frameworks of current theory, reaching toward understanding through the imperfect medium of human cognition. Our spacecraft have ventured only to the edges of our own solar system. Our radio messages have reached only a tiny bubble of nearby space. Our physical presence remains bound to Earth and its immediate vicinity. We stand at the shore of a vast cosmic ocean, dipping our toes in its waters, analyzing the composition of its waves, speculating about what might lie beyond the horizon, but not yet embarked on the great voyage of interstellar exploration that may await future generations. Our engagement with the cosmos remains mediated primarily through observation, rather than direct interaction, through the reception of signals rather than physical contact, through the interpretation of distant phenomena rather than immediate experience of them. But in that observation lies the seed of connection, the recognition that we are not separate from the cosmos, but part of it, not mere witnesses to its unfolding, but participants in its ongoing creation. The very atoms that compose our bodies were forged in stellar furnaces billions of years ago. The elements that make life possible were scattered through space by ancient supernovae. The matter that forms our planet was gathered from the interstellar medium by gravity's patient hand. We are, in the most literal sense, made of star stuff, the universe becoming conscious of itself through structures complex enough to support awareness, to wonder, to question, to seek understanding of their own origins. This material continuity between our bodies and the cosmos represents not merely a physical fact, but a profound metaphysical reality, a tangible demonstration that we are not strangers in an alien universe, but indigenous inhabitants of the cosmos, not accidental byproducts of random processes, but expressions of the universe's inherent capacity for complexity, organization, and consciousness.